Welcome back. Today we're going to finish our discussion on colligative properties. If you recall, we've talked about three colligative properties so far. The first, vapor pressure lowering. And that, of course, is related to the second, boiling point elevation. And the third, freezing point lowering or freezing point depression. Now, the fourth is something called osmotic pressure. And I know many of you have heard of osmotic pressure, but you don't necessarily understand what it is. So I hope for the first part of this video, I can illustrate that for you. Let's pretend you have a tube that looks like a U. They call these U-tubes, believe it or not. And separating these two tubes is something we call a semi-permeable membrane. Now, it's sort of like a molecular filter. Some molecules, if they're small enough, can move through it. Others, if they're too large, cannot. So in this U-tube, let's fill one side up with pure water. This is just pure H2O. And the other side, let's go ahead and fill up with, 10% sugar and water. So I have sugar water on one side and pure water on the other. Now let me just represent the side that has sugar dissolved in it with little dots. I know you can't see the sugar dissolved in solution, but we're just pretending we can, okay? Now, most of you remember from your biology class that osmosis is the movement of water from high water concentrations to low water concentration. So, don't I have a higher water concentration on the right side of my U-tube? It's pure water. And isn't the concentration lower on the left side because there's salt dissolved in it? So water will spontaneously move from high water concentration to low water concentration. So it's actually going to move through the semi-permeable membrane at a faster rate this way than it does going backwards. So what would this tube look like after a few minutes? Yeah, let's go ahead and erase this and show what it might look like after an hour. Wouldn't this side over here not be the same height any longer as this side over here? Does that make sense? We no longer have the same level of water on each side. This side on the left would be higher, and this side on the right would be lower, because the net movement of water would have gone from high water concentration to lower water concentration. Now, what does that have to do with osmotic pressure? Well, we've used the term osmosis, but what does that have to do with osmotic pressure? Well, let's draw that tube over again, down here at the bottom of the page. Okay, here's our semi-permeable membrane. Here's my sugar side, my sugar water side. And here's my pure water side. So remember, water is going to want to move from where it's highly concentrated to where there's less water concentration. Okay, let's say we wanted to stop that. So for that, let's put a plunger on this side. And let's start pushing down on it. And you'll say, well, how are we going to push down on it? Well, let's push down on it with, our finger, okay? So what I'm trying to draw here, kiddos, is a finger. We're going to be pushing down on that plunger. We're going to push down so hard, we're going to get the water to stop flowing. We're going to keep the water levels the same by applying pressure in a downward direction. We're going to push down on this plunger to keep the water level from going up. the pressure that we need to apply to prevent osmosis is called osmotic pressure. So the pressure we need to apply with our finger or whatever, we're pushing down with really, really hard. We're trying to get that water to stop flowing from high water concentration to low concentration. The pressure we need to apply is called osmotic pressure. And it shouldn't be surprising to you that it depends upon the concentration of the solute, not the type. So I could replace that 10% sugar water with 10% ethylene glycol in water, or 10% sodium chloride ions in water. And the osmotic pressure would be exactly the same. Remember, colligative property depends upon the number of particles, not the type of particles dissolved in my solution. So remember, kiddos, osmosis is the flow of water from high water concentration to lower water concentration. It flows spontaneously in that direction. And the pressure that we need to apply to stop osmosis from happening is called osmotic pressure. And the osmotic pressure is related to the concentration of the solute particles, not the type. Okay, so that's our fourth colligative property. You should be familiar with all four: vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. Now, in a future chemistry class, you may quantify this, and you may do some calculations involving these colligative properties. But for this class, you just need to know what they are. Okay? All right, kiddos, that's it for today. Talk to you soon. Bye-bye.